Hi all, welcome back to my channel. In today's session, I am going to explain you the internal architecture of 8086. Here you can see in the figure, the entire architecture is divided into two units, bus interface unit and execution unit. Why we are dividing the entire architecture into two units? This is to support the pipelining. That is, at the same time, this bus interface unit can fetch one instruction and the execution unit can execute another instruction. Firstly, we will discuss about bus interface unit. From the name itself, we can understand that bus interface unit, it acts as an interface. Interface of what? If we want to communicate this microprocessor to external memory or IO devices, if we want to take some data or if we want to give some data to memory or IO devices, it acts as a bridge between this microprocessor and this memory and IO devices using its bus system. The main functions of bus interface unit are: firstly, it generates a 20-bit physical address. By using that physical address, it will go directly to memory and will fetch the instructions from the memory. Then it transfers data to and from the memory according to our instructions. And this bus interface unit has a 6-byte prefetch queue to support the pipelining operation. Let's see one by one in detail. See the figure. This bus interface unit consists of 4 segment registers which is indicated by ES, CS, SS, DS, and then one instruction pointer IP, then one address generation unit that is indicated by sigma, and then one 6-byte instruction queue that is numbered as 1, 2, 3, 4, 5, 6. What is the purpose of using these segment registers? We know that 8086 has a segmented memory. That is, its entire memory is divided into 4 segments: code segment, data segment, extra segment, and stack segment. As I already explained, the starting address of each segment is called a base address or segment address. The base or starting address of each segment will be stored in the corresponding segment register. One thing we have to notice is that segment register and segments are different. Segment is in memory and segment registers are used inside the microprocessor. Here we have 4 segment registers. Code segment register will store the base address of the code segment, and similarly the base address of the data segment will be stored in the data segment register, and the base address of the stack segment will be stored in the stack segment register, and similarly the base address of the extra segment will be stored in the extra segment register. Next is the instruction pointer, which is used to store the offset address. Offset address that also I have explained in the previous video. So it is used to store the offset address of code segment. Next is the address generation unit, which will generate a 20-bit physical address using its segment address and offset address. Now let's move to the execution unit. Execution unit's function is to take the instructions from the instruction queue, decode the instruction, after execute that instruction and perform the arithmetic and logical operation using its arithmetic and logical unit. Let's see the different units in the execution unit. See the figure. It consists of 4 16-bit registers indicated by AHL, BHPL, CHCL and DHDL. The purpose of AX register is used to hold the operand and result during the multiplication or division operation. The purpose of BS register is used to hold the offset address during indirect addressing mode, and the CX register is used to store the count while using loop, shift, rotate or string operations, and DX is used with the AX register to hold a 32-bit values. Then the next unit is ALU. The arithmetic and logical unit will perform 8 or 16-bit arithmetic and logical operations. Then you can see in the figure there is some special purpose registers SP means stack pointer, which is used to indicate the top of the stack, and then base pointer, which is used to store the offset address of stack segment. Then the source index is used to store the offset address of the data segment, and destination index is used to store the offset address of extra segment. Next is the flag register. The 8086 has around 9 flags to understand the condition of microprocessor. The 6 status flags, which includes carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, and overflow flag, which will be set or reset according to our arithmetic and logical operation. Then there are 3 control flags: trap flag, interrupt flag, and direction flag, which will be updated during control instructions. Let's see the working of 8086 microprocessor. Firstly, our address generation unit will calculate the physical address by using the segment address and offset address stored in the corresponding registers. By using this generated physical address, it will go directly to the memory and will fetch the corresponding instruction. And it will be stored in the prefetch queue. And the fetching process will continue by this bus interface unit. At the same time, the execution unit will take the instructions from the queue and will decode the instruction and will execute that instruction. Then the next instruction will be taken from the queue and will be decoded and executed by the execution unit. Thank you.